Probabilities from Venn diagrams. Mathematicians like to have lots of tools in their tool belt, different ways of looking at a problem. We've already seen that you can solve probability problems where there are two different types of events using a two-way table. But we can solve the same kind of problem looking at it from a different angle, which can help to understand the problem when we can't understand it that way. And it also helps that we can see it visually in a diagram. And we're going to use Venn diagrams to do this. Venn diagrams are great when there are two different events and either of them could either be one thing or something else, true or false. For example, we'll use the same scenario as last time. Are pet owners more likely to be happy? Like last time, a survey asks 20 people 2 questions. Do you have a pet and do you feel happy today? The results were 6 people were happy, 17 people had pets, and 4 people were happy and had pets. When I say 6 people were happy, that means, maybe some of them had pets, some of them didn't, whatever. In total, you count the number of people who were happy, there were 6 of them. Let's put this in a Venn diagram so we can find out all the different other regions, for example, people who have no pets. All right, so I'll draw a Venn diagram. I've got 2 different categories here, happy and pets. So I'll put these as my 2 different circles. I'll label H for happy, and this circle will contain all of the happy people, and P for pets, and that will contain all of the pet owners. And this big rectangle and everything in it is you, the universe. Good. Right, so we could start filling in the numbers by looking at this one, 6 people were happy. And we could say, okay, well, that means that 6 people are in this segment here. What's wrong with that reasoning? Oh, 6 people are happy, so 6 people are in this moon shape here. The problem is, maybe there were 5 people in here and 1 person in there. There's still 6 people that are happy. What's the split between people in here and people in there? For that reason, I would suggest starting with the intersection, the people that are in both categories. 4 people were happy and had pets, so I can put a 4 in the middle. Now, when I look at this circle, I know that there are 6 people in the happy circle, 4 of them are over here. How many are left in this moon shape? There are 2 people left in here. Just to check, 2 plus 4, there are 6 happy people. 4 of them also have pets. We can do the same thing over this side to figure out how many people have pets but are not happy. And that's 17 take 4, which is 13 people. Finally, we can figure out how many people are neither. They're not happy and they don't have pets. Well, we know that there are 20 people in the whole rectangle, minus 2 of them are here, minus 4 of them are here, minus 13 of them are here. How many are left here? There's only 1 person left. And you can check, you can see, a number of people with pets, 4 plus 13 is 17 people with pets. That's good. You can add up all of these numbers and see that we have 20 people total. We didn't just invent people. All right, so now we've got our basic information here. We've pulled out all the different regions of the Venn diagram and filled them in. Let's figure out some probabilities. Let's find the probability that a random person in this group is happy or a pet owner. And when I say that, I mean happy or a pet owner or both. How many people are a happy or a pet owner or both? Woo. That is the union, which is these 3 sections combined, these 3 regions combined. So there are 2 plus 4 plus 13 is 19 people who are happy or pet owners or both. And that's 19 out of... Notice that we picked a random person in the whole group, out of all the people. How many people are there in total? There are 20 in total. So the probability of a random person being happy or a pet owner or both is 19 out of 20. Notice that when I write the probability, I've got therefore probability of, this says probability of happy or pet owner. This symbol is union for Venn diagrams. It's this yellow region combining both of them. And in probability, if you're looking at events, it's the probability of this being true or this being true, or both. So when you're looking at a probability problem, you can read this symbol as or, one or the other or both. We can also convert this to a percentage by putting it in your calculator and multiplying by 100 and putting a percent sign at the end to get 95%. Suppose that someone is happy. What is the chance that they have no pets? For this question, we're only focusing on the people that are happy. You could also have this question as given that would mean the same thing. Given that someone is happy would mean the same thing. And it means that we're going to only pick someone that is happy. We'll ignore all of these other people, and only pick someone from this happy circle. First of all, how many people are we choosing from? How many people are in this happy circle? There are 6 people in this happy circle. So we're going to randomly choose someone from these 6 people. And we want to figure out, if I randomly choose someone from this yellow circle of 6 people, what's the probability that they have no pets? How many of these 6 people do not have a pet? 2. There are 2 of these 6 people who do not have a pet. So now I've got my probability. There it is in words. I can write this as a fraction, 2 over 6. And the way that I write given that is this is the probability that someone has no pets given that. This line, this vertical line, means given that they are happy. So if I'm only choosing a person who is happy and ignoring all of the others, they can't be picked, then if they are happy, given that, what is the chance that they have no pets? And that is 2 out of those 6 people have no pets. And again, you could convert this to a percentage, put it in your calculator, multiply by 100%. Oopsie, and you will get 33%. I hope you found these videos helpful. Again, the more practice you get, the better you get. And check your answers, ask me for help, all those things. I'm more than happy to help you out. All right, good luck. Bye, everyone.